Hello Dream Team, we're going to have a quick look at sketching modulus graphs. So we have already been introduced to the modulus function, where basically it acts, if it takes some positive number, it just returns that positive number unchanged. But if it takes some negative number, it acts to make that negative a positive, so that would return 10. So in the context of a graph, it's going to flip the sign of this argument when this argument is negative. So when is this argument going to become negative? Well, it will change from negative to positive when x minus 3 equals 0. So it's going to flip from being positive to negative at x equals 3. So let's just put that point on here. That's x equals 3. This is actually going to be the vertex of our graph. And essentially we're plotting two different functions, okay? When x is going to be larger than 3, this is going to, the argument will be positive, and so my function will simply be y equals x minus 3. But when the argument is when x is less than 3, the argument will be negative, and my modulus function will flip that sign. So in essence, I actually have the function here. It will be minus 1 times x minus 3, which if I multiply that out is equal to 3 minus x. So really I have these two functions which will be branches on my modulus diagram. So all I'm going to do now is just pick a few points on each one of these and plot them completely normally, even though there's this discontinuity at x equals 3. So x will be, let's just choose some values that are bigger than 3, so 4 and 5. Y is x minus 3, so that's going to be 1 and 2. So x is 4, y is 1, x is 5, y is 2 here. And then on this other side, I have this very different graph. So let's pick a couple of points here that will make this one work. Don't know why I just scrolled there. So let's go x is 2 and let's go x is 1, x is 2, x is 1, x is 2. So y equals 3 minus x, so 3 minus 1 is 2, 3 minus 2 is 1. So I have x is 1, y is 2, I have x is 2, y is 1, and I have these two very different lines going like this. So that wasn't the straightest line in the world, but we kind of see the idea here. My function is decreasing as I approach 3 from the right, and then at the point 3, that argument would switch to become negative. So if it was just a normal line with no modulus symbol, my line would continue going this way. However, the modulus is working to change that negative to a positive. It's changing the sign on that argument, and so my graph is again growing up that way. Okay, so start with the vertex, get your two functions for the two branches, and then plot each one. So let's have a look at this. So my vertex is going to occur at 2x plus 3 equals 0. So it's going to occur at 2x equals minus 3. So it's going to occur at x equals minus 3 over 2. So minus 1.5. So my vertex will be here. Okay. As x is increasing, my function won't be changed at all by the modulus. So because the argument will already be positive, so that'll be 2x plus 3. On the other side, when that argument becomes negative, so when 2x plus 3 is a negative number, my modulus is going to change the sign on that, which effectively is like multiplying minus 1 times 2x plus 3. So this other branch is going to be y equals minus 2x minus 3. So now I have the two branches. One's going to be to the right, one's going to be to the left. I can just pick a couple of points, maybe not that many points. I was a bit keen. And plot these the normal way. So let's go with x is 0, x is 1. That's nice and easy. So 2 times 0 plus 3 is 3. 2 times 1 is 2, plus 3 is 5. And then on the other side, we've got to pick some points this way. So let's go with minus 3 and minus 4. So we have minus 3 times minus 2 is positive 6. Minus 3 is 3. And then I have minus 4 times minus 2 is positive 8, minus 3 is 5. So I can plot these points. So starting with the one that goes to the left, when x is 0, y is 3 here. And when x is 1, y is 5 here. And on the other side, I have when x is minus 3, y is 3. And I have when x is minus 4, y is 5. Yeah, that makes sense. I didn't really, yeah. Seems like we have two different steepnesses there. 3, y is 5. Minus 3, have I plotted that right? Yeah, minus 4. Minus 4 times minus 2 is positive 8, minus 3 is 5. Minus 3 times minus 2 is minus 6. Minus is positive 6, minus 3 is 3. Yeah, so those two seem okay. Or maybe they're not different steepnesses, they just look different steepnesses to me. 2x plus 3, 2 times 0 plus 3 is 3. 2 times 1, yeah, that seems fine. Whatever. Okay, last one. So we're going to find that vertex. So we have 1 minus x equals 0. So my vertex is at x equals 1. So that's going to be there. And then I've got my two formulas. So I've got my unchanged formula, y equals 1 minus x. And then I have this one, which is y equals minus 1 times 1 minus x. So that's, let's plot a couple of points for this one. So this will be to the right. So let's just go with x is 2, x is 3. So y equals 1 minus 2 is going to be 1 minus 2 is minus 1. 1 minus 3 is going to be minus 2. So x is 2. Y is minus 1 here, and then when x is 3, y is minus 2 here, like this. Okay, and then let's look at the second function. So I have positive x minus 1 on this one, yep, x minus 1, and then we'll be to the left this time, so let's just pick a couple of values to make that work. So x is 0, maybe x is minus 1. So when x is 0, y is minus 1. When x is minus 1, that's minus 1 is minus 2. So let's get both of those points on there. X is 0, y is minus 1. That looks symmetric, so that's nice. X is minus 1, y is minus 2. Nice. And so there is that one. Cool. Hope that helps.